Hello everyone, in this video I'm going to show you how to with SDC Verifier execute plate buckling, stiffener buckling and panel buckling verification based on the standard regulations. Before we start, I would like to say a few words about the model itself. For this calculation we are going to use the part of the ship structure which is executed from the plate and beam elements. All the stiffeners are executed from the beams while the rest part is completely done by the plate elements. Here we have two forces. This is like point forces, force 1 and force 2 in another location, and the simple support is applied around this structure in order to restrain our model. Okay, let's go to the SDC verifier, and before we start, let's analyze our model. Yeah, SDC automatically launched the Ansys mechanical. I do believe it will take several seconds. Okay, the model is analyzed and we can continue. A few words about the SDC structure itself, that we have our individual loads which based on the time step in Ansys mechanical. We combine our individual loads into load sets just in order to include partial safety factors. We can see that we include them for load combination 1 and for load combination 2, and in order to see the maximum overall results into one pictures, we use load group envelope, and it allows us to present it in one pictures in one table. Okay, next step is in order to calculate plate buckling verification, we need to recognize our panels, our stiffeners. Let's go to the recognition panel, press panel finder and press edit, and here in this window we can recognize our panels. We can do it in one click. Just press find. Yes, and you can see the all sections are recognized, and our section divided by the panels, plates and stiffeners. Everything can be tracked from here. Also we can go to the filter and filter them by the panels just to visualize how it's recognized. Press apply filter and select all, highlight in different color. Now we can see that our model is properly recognized, and we can even highlight our stiffeners to be sure that everything is done correctly. Go to SDC, select the stiffener, apply filter, and highlight our stiffeners. Yes. As you can see, the all stiffeners are highlighted and shown on the screen. I think we done. Yeah, SDC just adding the highlighting process, and we can continue with that. Okay. Press OK, and as you understood, we recognize our panels, we recognize our plates, we recognize our stiffeners, and we can go directly to the standard verification. And the first standard for this, we are going to use the Eurocode 3 standard. Let's add this standard to our model. Select backlink verification, and here appear the wizard window, which should be predefined before the verifications. The first one characteristic should be assigned the element position. This is like internal or outside compression elements. For this case, we can use internal, and it's already predefined to the model. Press OK. By the way, here is the restrictions where you can pay attention on. Press OK. Next one, for the outstand compression elements, we should select the case 1 or case 2, but yeah, we use the internal and we can leave as case 1. Next one is type of end position, rigid or non-rigid. Let's select non-rigid. By the way, everything is taken from the table 5.1. Press OK. Next three parameters is related as factors taken from the standard, and they can be even modified manually in case of some unique situations, but yeah, we will leave as it is. Next one characteristic is use plate average stress. In this case, we will see the one utilization factor per one plate. Sorry, otherwise we will see the local influence on our elements. For this case, I'm going to use the user plate average stress, and the second and the next one, this is like section characteristics. We can select we would like to calculate our complete model or part of them. For this case, we'll leave as a complete one. And the last one parameter is assign the value of the yield tensile limit, and they're already taken from the FEA model. You can see from here that everything is fully filled. Press OK and press OK. Now our standard is added, and we can calculate it, creating by the plot or table. Let's create plot, and here we should also predefine some settings. The first one is the load, for which we would like to calculate this verification. I'm going to select load group envelope to see the complete results of our model. Press OK. Next one is the element value, or like value on the plot. We are going to use the average on the plate. And the last one is what we need to select is selection of our model. I recommend slightly update it and present it in X separately direction and Y direction, just to visualize, just to better see our results. First one is X direction. That's okay. And press preview. The standard is calculated, and in a few seconds we will see our results. Yeah, now you see that one plate of our structure overstressed, and utilization factor, the maximum utilization factor above 1, and Yeah, while the rest one is within allowable limit. This is what related to the plates which lie in the global X plane. Let's create another plot where we put our plates in the global Y directions. No one, Y and Z. Okay. Need to press. Yeah. Press preview. Yeah, done. And as you can see, that maximum utilization factor is 0.11, and this is below 1, but we need to slightly update our legend just to be sure that everything is within allowable limit. What we can do, we can press OK and go to the settings, legend settings, and where we have our utilization factor from the automatic select min max and value 1.2 as a max. Press OK, and one more time replot. Yeah, now you can see that the plates in the which lie in the global Y direction pass the verification and the maximum utilization factor below the allowable limit. Okay, this verification related to the plate buckling, and we saw the two plots. But I would like to present our results in the table to clearly see what the plates do not pass verification. Let's create the uh, extreme plot, extreme table. Select our loads, this load group envelope, and press fill table. Okay, it takes 2 seconds. We need to wait. Yeah, done. As you can see in this table, we can clearly uh, find what the maximum utilization factor here in this bottom row, and also we can see that the maximum utilization factor per each section, and the maximum value appeared in the section X5 with value 1.04 with the based on the load set 2, which is crucial for that allocation. Okay, good. We can press OK, and table also stored in our standard tree. That was related to the Eurocode 3 verification. for our plate buckling. And the next standard which I would like to show you, this is the DNV plate stiffener buckling, and there is like more options how to calculate and what to verificate of our structure. Let's add DNV standard, DNV plate stiffener buckling, add, and here the same logic. We need to predefine several parameters. The first one is the resistance factor, which related to our material. By default is 1.15, which corresponds to the standard data. Next two options related to the material grade, yield, and tensile, and it's already implemented, taken from the FEA model. Next one is section, which basically section which we recognized previously. All our section we are going to analyze. Next one, parameters are related to the buckling verification itself. Here we can see the thickness factors. These factors allow us to calculate or take into account, for instance, if you have some corrosion damage, pitting, we can decrease this value and otherwise include it to decrease the plate thickness. Or even though if you would like to quickly check our structure with the thicker plate, we can do it with the thickness factor. Next one parameters is use plate average stress. This is probably common to the previous standard. We can use plate average stress and it allows us to see the maximum utilization factor over the plate, or do not use it and select average minimum or minimum mid-plane stress. This is like local influence on our elements. That would be like utilization factor per each element. Here we have the information button, and I recommend you to visit our website version of help, where we have the detailed descriptions what that means. For this calculation, we're going to use the average stress and also include the absolute shear plate average. Next one, parameters that we can calculate, that we can include our dimensions of plates which were recognized. Next one, option calculate design lateral pressure by formula 5.1, or we can manually adjust it. I recommend to use that one. And the last one, options related to the stiffener verification. PSC, this factor corresponds to the ratio of the smaller to larger design stress in the transversal direction, and SDC can calculate it automatically. It's taken as an average one, and we can leave as it is. And next one is the Z factor. This is like distance from the base plate material to the natural axis of our stiffener, and SDC can calculate it automatically, but we need to apply this number to the to our stiffeners, and we can like fill in these numbers and apply to selected. Press OK. And yes, all these parameters are done, and we can continue with the verification. Press OK. Here we see the three checks: the plate buckling, dimensions and limit, and stiffener buckling results. Here we can like calculate first of all the plate buckling, which I'm going to do, and next we will calculate stiffener buckling and compare that results with the Eurocode. Let's calculate plate buckling. Let's create plot, criteria plot, and as we did previously, we select our load group envelope, press OK, and we select our plate selection sections. First of all, we are going to use for the X direction and press preview. As you can see that based on the DNV standard, we have the overstressed area the same, but with the uh, bigger plates, because if we compare with previous one, it was like one plate, but right now is two plates. Okay, let's check our plates which lie in the Y global coordinate system. Press OK to store our plot. Create plot. Load group envelope. Press OK and select Y and Z. Preview. Okay, and here we can see that we need to one more time update our legend setting, because I see that that value is 0.62, but it should be like standard legend utilization factor min max. Okay, okay. Okay, as you can see that the maximum utilization factor is 0.62, which is below allowable limit, and this is appeared directly at the location where we applied our loads. And yeah, that's results quite comparable with the previous Eurocode 3 verification. Okay, let's then execute verification for the stiffeners. Maybe we need to create plot. Select load group envelope, and we can plot for the all 15 sections. I should press preview, and SDC start to calculate. It's almost done. Yeah, as we can see, uh, the maximum value of utilization factor in our stiffness appeared directly at that location where we have our forces applied to the FEA model. Okay, and let's build a table for those stiffeners. Stream expand table, load envelope, and for the 15 sections, field table. Okay, as you can see that for 15 sections, we have the maximum utilization factor with 8.15, and this is the maximum one. And yeah, we can also export that results to the component and see the calculation details, how it was calculated by pressing this button. In this calculation details, there is complete procedure how it's calculated. You can easily navigate yourself to find out where it came from, which numbers came from, and how it's calculated. Press close. Close. OK. Okay, that's what related to the plate buckling and stiffener buckling. And the last one verification which I would like to show you, this is panel buckling, and we need to do some manipulation to do that. As you can see, before we start, we need to convert our DNV standard to the custom, and after that integrate several formulas for that. Let's convert it to the custom. Press OK and add new standard. Add custom standard. We'll call it panel check. And this check will be based, the background of this check will be like based on the plate verification and the stiffener verification, and we can extract this utilization factor directly from the previous calculation. Let's do that by pressing this button. We can select this characteristics, like from the DNV plate buckling, we are going to use the buckling factor overall. Press OK and call it plate check. Let's assign the alias. Press OK. Next one step, we need to take the maximum overall utilization factor from the stiffeners, and let's do it. Press plus. Select our characteristic value, stiffener buckling, max utilization factor overall, and press OK. Let's fill in name and alias. Press OK. And next one will be like the utilization factor of our panel buckling. It would be maximum utilization factor from both of them. Let's do it in this way. We call it panel check. And add our previous characteristics which we used previously. This is plate check. Wait a second, we need to add amps max, and here plate check. Here stiffener check. Press OK. And in order to represent our failed panel structure, what we need to do, we need to also integrate one more formulas to highlight them. Just press add, and it will be utilization factor utilization factor. And here will be if our utilization factor of the panel check is above 1, it's equal 1, otherwise it's equal 0. Press OK. And in order to better visualize this, we can slightly update, add some function. This is at the edit multiple parameters. We select our parameters and assign them characteristic as utilization factor set, and highlight everything with the above 1 with color red. Set, press OK, and press OK. In this case, we are going to see the panels which are going to fail, which has a background based on the utilization factor of the plate buckling and the stiffener buckling. Press OK. And let's build our table. For this case, we need to build component table, and we are going to our panel finder, press edit, and we need to export all our panels as a one component to execute this verification. Go to the filter, select the panel, apply filter, then we select all of them and export to the components as a separate component. That way we receive the 81 separate components of our model. Export, press OK, OK. And now we need to build this component extreme table. Select our components which were created previously, press OK, and select the parameters all, press fill table. And here you can see that there is a list of our panels which doesn't pass the verifications. It's based on the plate check and stiffener check, and we can even highlight them by pressing Ctrl A and select this label plot. Select panel utilization factor. It will take several seconds. We need to wait, and Ansys Mechanical will build the plot. Now it's done, and SDC analyzing everything. Yeah, now it's done, and we can see clearly that this section doesn't pass verification in this calculation. Here is some values, but we can turn off this by the remove graphs. Now it's better to visualize. Yeah. Okay, good. I hope everything was clear, and yeah, thank you for your attention.